Welcome, fellow explorers, to another thrilling episode of our speculative evolution journey. Today, our expedition takes us deep into the rainforests of Verdant Tara, where life has undergone remarkable adaptations to thrive in this lush, verdant world. The equatorial regions of Verdant Tara receive the highest amounts of solar radiation anywhere on the planet. This provides energy for photosynthesis and facilitates a constant hot and humid climate. Areas near the ocean will receive extreme amounts of rain, facilitating abundant plant growth, which will result in ecosystems teeming with fascinating organisms uniquely adapted to their respective habitats. Our first stop is the Mavussos rainforest on the north shore of Zyraphelios. The humid environment of this forest allows descendants of the Tundophyta to flourish. These plants may specialize for large sizes. This allows them to outcompete other plants, thus gaining access to the highest amounts of sunlight. Their roots and trunk will expand, providing a wide and sturdy base. This adaptation can be seen in similar plants on Earth. The drip tips of the ancestral Tundophyta will be quite useful, preventing their leaves from being damaged due to water buildup. These towering pterophytes, which we'll call the Pyrgophyta, can grow from 20 to 40 feet tall, providing the base for a lush ecosystem to come. The evolution of the Pyrgophyta divides the rainforest into distinct layers called the forest floor, the understory, and the canopy. The main difference between these layers is the availability of sunlight, with the forest floor being extremely dark because most of the light is blocked out by the dense canopy above. This means that the forest floor will be mostly barren of vegetation. However, one descendant of the Vulvophyta may specialize for this habitat. One of the main problems the Vulvophyta may face is reproduction. The larger plants like the Pyrgophyta block most all wind, preventing the Vulvophyta from using the wind to spread their reproductive cells. Therefore, the Vulvophyta may need assistance from other organisms to reproduce. On Earth, many plants call upon animals to help them reproduce. The first step the plant must take is finding a way of attracting a pollinator. These plants may opt for a strategy referred to as deceptive pollination, which involves the plant mimicking something of interest. These pterophytes will mimic the smell of rotting vegetation or flesh. When they do attract an animal, they will need a way of attaching their reproductive cells. To do this, they may evolve organs from which their pungent smell emanates. These organs will be fitted with hairs that attach the cells and repositories to receive cells. These pterophytes will be called the Xyranthia. Among the inhabitants of the Mavussos rainforest, the Hexo forms will be some of the most abundant. Up until now, they have relied on their small size and rapid reproduction to survive, but the rainforest represents innumerable opportunities. Camouflage will be seen in many of the rainforest's inhabitants, but some organisms may take this to a greater extreme. Defensive mimicry is a strategy in which the mimic evolves to resemble another species called the model. This resemblance means that predators may not be able to distinguish the mimic from the model. The model is most commonly a species that predators have no interest in, allowing the mimic to hide in plain sight. This results in an arms race in which the predator must evolve to distinguish the mimic, and the model, which then pushes the mimic to evolve a more convincing disguise. The Xyranthia will be the perfect model for one branch of the Hexo forms. Along with a rounded body, these creatures will sport hairs on their backs, resembling the hairs of the Xyranthia. These small mimics will inhabit the groves of Xyranthia, feeding on them. When a predator appears, these creatures will simply remain still until the predator passes them by. We will call these disguised Hexo forms the Cryphopod. These stealthy creatures can grow up to 5 centimeters and live for up to 7 years. However, there is another way the Hexo forms could protect themselves. Many animals on Earth have evolved potent toxins to ward off predators. Toxicity is most commonly seen in smaller animals such as the poison dart frogs of Earth. This may result in one clade of Hexo forms evolving a potent toxin that causes an extreme burning sensation on contact. Unfortunately, poison does no good if the animal dies before it takes effect. Therefore, similarly to poison dart frogs, These creatures will evolve a variety of bright patterns consisting of greens, reds, and yellows in order to stand out against the purple vegetation. Over time, predators will learn to avoid these displays in order to avoid a painful encounter. This form of defense is called aposematism. We'll call this clade of hexoforms the epidermata. They can live for up to 10 years and grow up to 10 centimeters. As we exit the forest floor, we enter the understory. On this level, access to sunlight increases, providing more energy to plants. Plants in this region may use the trunks of the pyrgophyta as a platform. This allows them to gain access to more sunlight than they otherwise could. Epiphytes are plants that grow on other plants, such as the bromeliads of Earth. Another descendant of the Vulvophyta may specialize for an epiphytic lifestyle, growing elongated stems that adhere to the trunks of the pyrgophyta. These plants will specialize for asexual reproduction, allowing for branching colonies between multiple trees. Since the pyrgophyta don't have any branches, this plant will form a large part of the understory. We will call these branching epiphytes the Anarophila. As the Anarophila spread, a descendant of the syntodont takes to the trees. As one descendant of the ancestral climbing syntodont specializes for the trees, they may become so adept at climbing that they spend almost their entire lives in the trees, only venturing to ground level in extreme cases. This lifestyle is reminiscent of spider monkeys on Earth. On Earth, there are numerous ways animals traverse the treetops. Certainly one of the most specialized forms of locomotion is brachiation. Brachiation is an extremely rare form of locomotion only seen in primates on Earth. It involves the animal swinging between branches arm over arm. On Earth, the gibbon has perfected the art of brachiation. They can reach speeds of up to 50 kilometers per hour. This speed is useful for covering long distances and avoiding predators. With all these factors in mind, it seems reasonable to assume a clade of syntodonts may evolve this form of locomotion. One adaptation typically seen in brachiating species is long arms. Therefore, these forms may exhibit some of the largest arms relative to body size of any serpentopods. Another adaptation seen in many climbing species is a prehensile tail, such as the one seen in chameleons on Earth. This creature will also have a prehensile tail, which will aid it in foraging in the trees. Their hands may evolve into hook-like structures used to grapple to branches. Most species in this clade will be herbivorous, with only a few, if any, being carnivorous. An herbivorous diet is supported by their generalist ancestors who ate both plant matter and flesh. These creatures range in size, with the smallest being around 1 foot and the largest growing up to 4 feet. We'll call these clambering creatures the Brackopods. Yet another clade of syntodont may arise closely related to the Brackopod. These forms will be adapted for a predatory lifestyle, with most species simply feeding on hexoforms. However, a few species may evolve a much more unique hunting style. On Earth, animals like snakes and the Amazonian giant centipedes hang from branches and snatch up any passing prey like bats or birds. The smaller species of Brackopod offer a perfect candidate for this hunting style, as they are small enough to be grabbed even at high speeds. Therefore, the syntodonts with this hunting style will evolve longer bodies, and similarly to the Brackopods, they will also have a prehensile tail. We will call these unique hunters the Arpazontas, with the largest among their ranks growing up to 5 feet long, living for up to 14 years. As life in the Mavuso's rainforest continues to flourish, we cross the sea to find ourselves in the Pyophygro's rainforest on the southern shore of Xyranthia. Here, descendants of the cladophyte have evolved into the tallest organisms on the planet. Similarly to the pyrgophyta, these pterophytes have evolved a wide base for support, sturdy bark, and drip tips. Unlike the pyrgophyta, these trees have sprawling branches, which allow them to spread their seeds as far away from the parent plant as possible. These organisms can grow up to 80 feet tall. We will call these giants the Stagnophyta. Due to the height of the Stagnophyta, areas like the understory and canopy will be more spacious, providing room for larger animals. Additionally, due to the sheer density of the canopy, almost no sunlight will reach the forest floor, therefore preventing any plants from growing there. One of the first creatures to take to the trees are the descendants of the steppe-dwelling Zyraphelios. These forms have adapted to life in the trees with larger feet and longer legs to grip to the surface of trees. Additionally, these creatures' beaks have become riddled with tiny air pockets to reduce weight. Most creatures in this clade will be omnivorous, with some herbivores and carnivores. We will call these adaptable tree dwellers the Climbrachia. They can grow up to 4 feet long and can live for up to 17 years. Unlike the Pyrgophyta, the Stagnophyta have sprawling branches, which represent a prime opportunity for epiphytic plants. One clade descended from the Kólopatópod may evolve to live only on the Stagnophyta, never making contact with the ground. However, similarly to the Synanthophyta, these plants will face issues when it comes to reproduction. Therefore, they may also evolve a form of animal-assisted pollination. These plants will offer a reward for potential pollinators. This results in the pollinator being incentivized to find the plant as easily as possible. On Earth, this results in extreme cases such as the swordbill hummingbird, which can only feed on one type of flower. Therefore, in order to attract potential pollinators, these plants will produce a sweet nectar at the end of tubes. These tubes will be lined with the male gametes, ensuring that when an animal goes to drink the nectar, they are coated with gametes. These plants will be colored in hues of bright yellow to stand out against the purple vegetation. We will call these colorful pterophytes the Zyraphelios. As the Zyraphelios evolve these adaptations, the Climbrachia will evolve with them. It may start with the Climbrachia occasionally attempting to drink from the plant, and over time they will become more adept at accessing the nectar. In order to access more Zyraphelios, these creatures have to climb from tree to tree. However, there is another much more efficient way of moving from tree to tree. Many climbing animals on Earth have evolved a patagium, which is a thin membrane used as a sort of parachute. This is useful for surviving long falls and gliding from tree to tree. Therefore, these forms will be the first gliding animals. This adaptation will allow them to move from tree to tree with ease. However, some members of this clade may take this to a greater extreme. Powered flight is quite rare on Earth, having only evolved 4 times in the history of life. But it is reasonable to assume that with the sheer biodiversity of the rainforest, these gliding Climbrachia may eventually evolve powered flight. But this is no easy task. There are multiple key adaptations these creatures will need to undergo before they can take to the air. Firstly, their bones will become less dense in order to reduce the effort needed to stay in the air. Their narrow beak used to extract nectar offers an aerodynamical benefit, decreasing drag. Lastly, the Climbrachia will need to make changes to their respiratory system. All descendants of the Kólopatópods have 1 heart and 2 lungs. In order to pump enough oxygen to supply the body, they may enlarge the heart. When the heart beats, it will push against the lungs, therefore releasing air, and when the heart contracts, air will rush back in. This, combined with their already efficient active respiratory system, will allow them to finally take to the air. These are the only flying animals on Verdant Tara, and will therefore have a monopoly over the skies. They will be called the Pinotoped, and we will discuss their diversity in much greater detail in a future episode. Another branch descended from the Climbrachia may specialize for yet another form of climbing. Suspensorality involves the animal hanging below the branches rather than climbing on the top of them. This form of locomotion is exhibited in sloths among other animals on Earth. Suspensorality allows animals to negate the issue of balancing on tree branches because they are already suspended. These forms will evolve long claws to make it easier to hang on branches indefinitely. These forms, which we'll call the Antilopoda, will be mainly herbivorous, only feeding on small animals if necessary. The Antilopoda can grow up to 6 feet and live for up to 20 years. As of now, the Zyraphelios have been thriving in relative abundance, but one issue that they're facing is seed dispersal. As of now, the seed either falls to the forest floor and dies, or lands next to the parent plant, thus needing to compete with its own parent. One way plants on Earth solve this problem is by evolving fruits that get eaten by animals who then spread the seed through their fecal matter. This form of seed dispersal may be seen in some species of Zyraphelios. Once they are fertilized, they will grow a fruit on the end of their nectar tubes. This fruit will be filled with tiny seeds. The fruit will be bright red to contrast against the purple background and the Zyraphelios themselves. We will call these fruit-bearing Zyraphelios the fructophyto. The fruit of the fructophyto represent an untapped food source. Many species of Climbrachia may incorporate these fruits into their diet, but one descendant of the Scantopelma might evolve to feed on these fruits alone, becoming the planet's first frugivores, which are animals that feed on fruit. They may become smaller to move from tree to tree quicker, but the smaller the organism, the more danger. Similarly to the Hexo forms, these small Scantopelma will need a way of protecting themselves. So, similarly to the epidermata, these creatures may evolve a form of toxin. This toxin will cause predators that ingest it to vomit and become sick. They too will be fashioned with bright warning patterns. These creatures will live in and around patches of fructophyto. We'll call these dangerous critters the anethesipod. They can grow up to 1 foot and live for up to 7 years. However, once predators learn to avoid these creatures, the system is open to exploitation. The anaeropods and their relatives are almost certainly clambering among the branches. One offshoot may have similar predators as the anethesipod. These predators already know to stay away from the anethesipod's black and green coloration, so rather than develop their own toxin, these creatures will just copy the anethesipod. Therefore, when a predator sees this creature, they will associate it with danger. We will call these deceptive organisms the Pinotoped. They can grow up to 1 foot long and live for up to 10 years. Additionally, the Pinotoped have some of the first primitive teeth used to feed on fruits. Finally, we venture to the Galazia rainforest of Zyrrakor. This rainforest spans most of the 3 islands of Zyrrakor, offering innumerable opportunities for life to flourish. Here, descendants of the tundra tropicae have adapted to take full advantage of the abundant sunlight and humid climate. Yet again, they convergently evolve a wide base and sturdy bark. However, the leaf structure of these plants is unique. They sport a disc-shaped leaf, which doesn't allow for the formation of drip tips. These chromatropes solve this issue in a rather simple way. Since their leaf originates from a single point, their leaves will simply fold downward to get rid of water. These chromatropes will create sprawling blue forests across Zyrrakor. They can grow up to 40 feet tall. We will call them the Dendroforma. As the Dendroforma take hold, a descendant of the Kólopatópod quickly takes to the trees. These creatures will be small and nimble, feeding on any creature smaller than it. However, due to its small size, it will be exposed to larger predators. So, rather than running, these creatures may go on the offensive. Unlike poison, which needs to be ingested, venom needs to be directly injected into the bloodstream. These creatures' venom may evolve from glands that were used by their early land-dwelling ancestors to create a moisturizing slime. These glands will congregate in the beak of the creature, running down grooves in the beak onto the puncturing tip. These creatures will want to advertise their danger, similarly to the rattlesnake. These forms will accomplish this with bright red warning coloration on their shells. We will call these venomous organisms the Kindinodus. They can live for up to 16 years and grow up to 2 feet. Similarly to the anethesipod, once predators learn to avoid the Kindinodus, the system is open to exploitation. It is highly unlikely that another species of quadrupod would evolve the same venomous abilities as the Kindinodus, so instead descendants of the ancestral quadrupod will attempt to trick predators. They will evolve a similar shaped shell and similar aposematic coloration. We will call these deceptive mimics the Cephticonodus. They can grow up to 2 feet long and live for up to 12 years. A relative of the Cephticonodus may adapt to live in the canopy, becoming an expert climber. They will accomplish this in a unique way. Geckos on Earth have evolved special toe pads that allow them to climb straight up vertical surfaces. These toe pads are equipped with tiny hairs that provide grip. A similar structure may emerge in these creatures, allowing them to climb and clamber along trees without worry. We will call these nimble creatures the Kólopatópodia. They can live for up to 19 years and grow up to 2 feet. Yet another epiphyte may come in descendants of the Chromatropici. These epiphytes will bore into the bark of the Dendroforma, creating large colonies coating the tree, similar to how some fungi grow. These chromatropes will leach off of the Dendroforma, but not enough to be a serious problem. We will call these bright red chromatropes the Frugivores. The Frugivores represent a new food source, which a relative of the Kólopatópodia may evolve to feed on. However, like the Climbrachia, they will need to climb between branches to access groves of Frugivores. This may result in another instance of gliding. These forms will have 4 membranes between their legs, and as they descend, they will spin in a similar fashion to a maple tree seed. Their skulls will evolve to tolerate such high levels of rotation. We will call these unique gliders the Spinelexal. They can grow up to 3 feet and live for up to 20 years. Another clade descended from the Kólopatópod may deploy yet another type of mimicry. Aggressive mimicry is used by predators to lure in prey by mimicking something of interest like food. An ideal model for aggressive mimicry would be the Frugivores. Therefore, these Kólopatópod will alter their shells to resemble the Frugivores. They will position themselves within a patch of Frugivores and set their legs in a position that resembles roots. Once prey comes to feed, it will lunge out and grab them. We will dub these aggressive creatures the Kólopatópod. They can grow up to 4 feet and live for up to 23 years. From the towering Stagnophyta to the stealthy Kólopatópod, each creature in the rainforests tells a tale of abundance. As Verdantara's continents continue to evolve, so too will its inhabitants. What extraordinary possibilities lie ahead? In the next episode, we will explore the many offshore islands of Verdant Tara and the countless unique ecosystems that form on them. Thank you all so much for watching. I know a lot of you have been waiting for this episode, and it's finally here. I appreciate the support. Don't forget to like, subscribe, and share your thoughts. See you in the next one.